So what does it look like when this face seal fails or sticks, or, you know, our customers saying, hey, something's wrong here? This is what it looks like. A couple of case studies on the right-hand side. When in extreme situations, when the seal pulls out of the gland from sticking, the valve doesn't know that the seal is pulled out. It continues doing its thing, and basically it's mechanically cycling. And when the seal pulls out and the valve continues to cycle, you're basically shearing that O-ring. And you can see it in those pictures on the right-hand side. There's three of them that show the paddle with an O-ring that's been sheared. And these are from actual case studies from etch equipment. And then in the very far right picture, it's not the best, but it's an internal shot of the valve with some seal material hanging out of the groove in there. An actual real-time picture from some of the case studies that we've seen in the field. Now, again, this is extreme. Popping out of the gland is extreme, but it does happen. And it happens more when there's chemical attack on your seal, which is always going to be happening. It happens more when your seal or this valve is closed for extended periods of time. So the longer this valve is closed, the higher the tendency of seal materials to stick in this application. So, chemical attack, typical cracking, what else does it look like? This is what it looks like. Chemical attack is actually taking a nice material like you see here on the top, nice and smooth, right out of the mold, clean on the surface, and it's basically destroying the material. It's molecular, or chemically attacking the material. There's no elastomer material that can resist these environments. So you're basically managing this type of erosion and chemical reaction. So what you see here on an exposed sample is what we call the gel effect, right? So this is like a clear gel that forms on the surface of a seal in these valve applications, specifically the face seal. And what happens is this gel forms on the surface, and then this valve closes, and this surface gets pushed against the paddle. So you can imagine this gooey type of surface wants to stick to the paddle. It also wants to like smear on things, and you'll see like what we call threading effect sometimes in this application, where you'll see this broken down material on the edges of the seal because you're smearing it all over every time you actuate the seal and close it. So the longer the seal runs and the more chemical exposure and cycles you put on it, the more extreme this effect becomes. Typically, the part will crack before it will pop out of a groove from sticking effect. But popping out of a groove from sticking is not the only thing you need to worry about, because if your paddle is delayed from opening, that could also cause you a timeout in your system, right? You say open isolation valve so that you can start flowing gas, or pendulum valve so you can start flowing gas, but it doesn't open. It doesn't open quick enough, and it could fault your system out as well. It doesn't have to pop out of the groove, but it could still be a sticking issue. We've also seen this lead to particle issues from both of these seal locations. So the second location is the piston bore type of seal application, the radial seal in this seal plate. And this seal plate's moving up and down, and this part wants to roll. This is a typical seal failure in this application. Materials want to roll in this application as that plate moves up and down. Now, it doesn't move that far, right? So you probably say to yourself, well, how can it roll and twist that bad, moving less than, I don't know, 1/4 of an inch? But the bottom line is it doesn't take much to make seals twist. And installation of this part is pretty difficult. So twisting and installation is also a big part of this as well. This is a very typical seal failure. You can see it right here. These are two different seal failures that you see here on the right-hand side of these case studies. And that's the actual cracking that we see. And sometimes parts come back in pieces. And you can imagine that this is no longer a good seal.